Okay, we're going to do this part really quickly because you already know how to do this. 16 to the 3x, so we're on the next page. 16 to the 3x is equal to 8. How do we solve for x? First of all, try to look for something that's simple, right? Can we change 8 and 16 into the same base?
Yes.
Yes. What would be the base?
2.
2. Okay, so 16 is 2 to the what power? 4. So 4 times 3x. And then 8 is 2 to the what power? 3. All right, because they have the same base, their exponents must equal. So this is 4 times 3x equals 3. So that is 12x equals 3. X is 3 over 12, or 1/4. Easy. Right, so as long as you can tell whether they have the same base or not, you can solve this pretty easily. Okay, so let's go ahead and have you practice 1 and 2. All right, number 1. Allison, what'd you get? 4 over 9? Okay, yeah, so 27 is 3 to the 3rd, so that times that 3x there. 81 is 3 to the 4th, so then we make them equal to each other, 4 over 9. Trey, number 2.
-5/3.
No. Okay, so this 1 over 125 is the problem, right? So 125 is 5 to the what power?
-5.
Just 125. 3. So 1 over 5 to the 3rd. So this becomes 5 to the -3. So then 3x is equal to -3. And x is equal to -1. 15 to the 3x is equal to 285. 15 to the 3x is equal to 285. Can we change 15 and 285 to have the same base? No, we cannot. So we cannot solve this problem using the simple way, which is just making the bases the same. So what we can do is we want to solve for x, which means I need to get that x down. It's in the exponent right now, so I cannot solve it. I have to move it down. To move it down, I have to take log on both sides. Log is the only thing I know that we can do so that we can move the exponent. So whatever you do to one side, you have to do it to the other side. So log on both sides, and we're going to move that 3x down. So this is 3x log 15 equals log 285. Okay, remember I am trying to solve for x. I'm trying to figure out what x is. So log of a number is really just a number because if you type it in your calculator, that's just a number. So what I can do is I can move this around. So this is x times 3 log 15 because that's just all the numbers equals log 285. All right, the last thing I need to do to solve for x is just divide everything that is not x next to it. So x is equal to log 285 divided by 3 log 15. All right, and that is the answer. At this point, you do need to take out your calculator and solve. So everyone, please take out your calculator. I'm going to show you how to use your calculator to do this correctly. Because there are 2 things in the denominator, you need to be careful. You need to write it like this. If you like to write all of them together, all at once on your calculator, this is what you do. Log, parentheses, 285, close parentheses, divide. At this point, you need to put all the denominator in one big parentheses. So parentheses, 3 log parentheses 15, close, close. Okay, if you're gonna do a one long thing on your calculator, this is what you do. All right, so go ahead and do that and let me know what number you get. Anyone want to volunteer your answer? No. Rula? Oh, Daniel? Oh, she didn't raise her hand. I just called on her. 0.7, yes. Let's not round too many, so let's do 6, 9, 6. All right, let's try another one. Number 1 over here. All right, so first thing you always ask yourself is, can I change them so they have the same base? Can 5 and 130 have the same base? No. Okay, if they can't have the same base, then make them have the same base. You solve it faster that way. Okay, no, they cannot have the same base, so what should I do to move that 2x down? Log, okay, log on both sides. Okay, so then I'm going to move this 2x down. 2x log 5 equals log 130. Now what? I need to get rid of everything that is not x next to x. Sorry, Nathan raised his hand. 2 log 5 equals log 130. Okay, good. And then Andrew, you were going to say?
I'm going to say the same.
Oh, you were going to say?
Wait.
Now what?
You divide 3 log 15? Or
2 log 15?
2 log 5.
2 log 5? Yeah. So x equals log 130 divided by 2 log 5. All right, go ahead and do that. Get an answer. Let me know when you're done so I can double check. All right, what are we going to do next? Any thoughts? Any thoughts? No thoughts? I'm going to call on random people. Andy. What are you going to do next? Or what did you and Sebastian say? So you're going to distribute? Is that what you're saying?
Yeah.
Okay. Yes, we can distribute, but it is not going to make this problem easier. It's going to make it harder. So what should we do? Yeah?
Divide log 144 by log 25.
Yes, we should divide by log 25. What happens is log 25 is already a very annoying number. If you distribute now, you have to double the log 25. So you don't want to distribute. You want to just get rid of it. So this is going to be 2x plus 1 equals log 144 divided by log 25. Okay, at this point, if you're looking at it and you say, oh, this looks so scary, then just go ahead and evaluate this and get a number. Because once you see that it is just a decimal, then you wouldn't be so scared. But I would strongly suggest that you don't do that, because if you don't, then you kind of push your math skills to a little bit better level. Okay, so let's say that you already got that into a number. What should you do next? Subtract 1. So 2x is equal to log 144 divided by log 25 minus 1. And then what's the last thing you need to do? Divide by 2. So x is equal to log 144 over log 25 minus 1 and all over 2. Yikes. All right, so you may not want to put that whole thing in your calculator. You might want to do it one at a time. Okay, do it, write down the number, and then do the next steps. Okay, go ahead and figure out what that number is. Let me know when you're done. Number 3, the answer is 0.272. Okay, 2 and 4. Number 2, the answer is 2.092. And number 4 is 2.794. Any questions? No questions. All right. Okay, so kind of to summarize, when you have something to an x, if both sides can be changed to the same base, do that. Only do log if you cannot, because you're just taking the long way to solve an easy problem. Okay? Next, Solve this equation. Log of x minus 3 plus log x equals 1. That's kind of strange. First of all, log shows up in two places, and x shows up in 2 places. So this is hard to solve, except we're going to remember our log rule. Log rule says if you have 2 logs that have the same base and there's a plus sign in between, what can we do to those things that's inside the log? Huh? Someone said the right answer. A plus means multiply. Okay, so what we can do is multiply them together. Log of x minus 3 times x equals 1. All right, that's great, but that doesn't help us solve this problem. Now what we have to do is look at this problem with the base. What base is this log? 10. So when there is no base, it is assumed that it has a base 10. So what you can do is you can do the loop rule. 10 to the first is equal to x minus 3 times x, and then kind of solve it that way. But most people will not solve it this way, so I'm going to tell you how most people actually solve it. Okay, again, the base is 10. So what we're going to do is we are going to recall that one of the log rules says if you have an exponent that has the same base and the log of the same base, it cancels. So this is a log base 10. What I am going to do is raise both sides by 10. Meaning I am going to force this whole equation to become exponents. Okay, I'm going to raise both of them by 10. Okay, and then so this is going to cancel because the base of the exponent and the base of the log are the same. So that was log rule number 7, I think, the last rule on that sheet. Okay, so that cancels, and we just get x minus 3 times x equals 10 to the first, which is 10. Either way, both ways gets you to the same equation. Okay, again, the key is look at the base of the log. Whatever that base is, you raise both sides by that same base. Okay, anyways, let's solve this problem. How do I solve this problem? X minus 3, so I'm looking at the right-hand side. X minus 3 times x equals 10. What should I do to solve this?
Distribute the x.
Distribute the x. So x squared minus 3x equals 10.
Subtract 10.
Good. Okay, we need to make sure it equals 0. Now what?
Factor.
Factor. So x minus 5 times x plus 2 equals 0. So x is equal to 5 or minus 2. Last thing, we need to check because one of the answers may not work. So we had to plug it back into the original problem to solve, to check. So you're just going to plug it into your calculator and check. Are you guys done copying down this part? Yeah?
Mm-hmm.
Okay, all right. So let's see. X equals 5. So this is how you check. You plug it back into the original equation. So log 5 minus 3 plus log 5 equals 1. You're going to check to see if that's true. And then x equals minus 2. Log of minus 2 minus 3 plus log of minus 2 equals 1. So you're going to check. Okay, so go ahead and plug it back into your calculator and see which one works. If it doesn't work, your calculator is going to say error. 5 works. And then if you put in -2, your calculator says error, right? Okay, so I'm going to tell you a faster way to check this answer. What you're looking for is just that inside the log, you cannot have a negative number. Because remember a few sections ago we said log of a negative number is no solution. So whatever answer you get, just mentally check. Does it give a negative number inside the log? If it doesn't, then that's the correct answer. So it's kind of a faster version of this. All right, let's try one together. Number 1, log 6 minus log 3x is equal to negative 2. Okay, what should we do first? Can we combine the logs together? Yes. Why? Same base, because they have the same base. Okay, and then so there's a subtraction, so what should we do to combine them together? Divide 6 over 3x. Good. Now what? What's the base on this log? 10. Okay, so I should raise both sides by what number? 10. Okay, so I'm going to raise both sides by 10. That's gone. 6 over 3x is equal to 10 to the negative 2. 10 to the negative 2 is what? 100. 1 over 100. Okay, so now what you want to do is cross multiply and solve. Cross multiply and solve. Okay, number 1, the answer is 200. Number 2, if you try that, the answer is 2,000. Okay, let's look at number 3 together. What should we do? Can we combine these logs together? Yes. Okay, but what has to happen first before I can multiply them together? Huh? Okay, I got to move that 1/2, right? So the 1/2 goes on the top. So this is log of x to the 1/2. X to the 1/2 is just square root x plus log 4 equals 2. Okay, I did see a wrong answer or wrong process, but I think it's a good time to talk about this wrong process. The wrong process is to distribute this 10 everywhere. You cannot distribute this 10 everywhere. You have to combine them into one big log first before you can raise both sides by 10. Okay? Please be careful. This is a very common mistake. People just distribute. Exponents are not linear. You can only distribute things that are linear. Okay, so we're going to combine them together. Log 4 root x equals 2. What's next? 10. Yeah, raise both sides by 10. Okay, so this is 4 root x is equal to 100. Okay, you guys can solve this, right? Yes. Okay, go ahead and do this one. This answer is 625. And if you tried number 4, the answer is 200.8.